Greetings and welcome, friends. Mr. Waddy here today. It's a big day. We are going to master the step one of the elimination method. Step one. That's right. Yesterday, we mastered steps 2 through 4 when step one was already done for us. And we did a little bit of step 1 where we kind of had to rearrange some terms so that they lined up in columns. But today, step 1, in case you don't remember, I'll show you why it matters in this problem right here. Right, to solve the system, if I was to try to add these together, when I added these terms, I would have gotten negative 15x. That doesn't get eliminated. If I was to add these terms, I would have gotten negative 3y, not eliminated. So I can't just do step 2 until I have opposite coefficients for one of the pairs of like terms or variables. All right, so that's what step 1 is. It says multiply, if necessary, one or both equations by a constant, so at least one pair of like terms has the same or opposite coefficients. So I said we're going to avoid the same and subtract. We're going to focus on opposite and adding. All right, is what my strategy is. I just keep it the same every time. All right, so for step 1. All right, let's take a look together at this. I want to get opposite coefficients. All right, so for step 1, if I was going to get opposite coefficients for the x's, all right, there we go. Notice that right now I've got a negative 10x and a negative 5x. What I'm going to look for is a number that both 10 and 5 go into. I'm looking for the least common multiple of 10 and 5. And in this case, just like if you were finding a common denominator, right, if I had a fraction that was like 1/5 plus 3/10, I'd need to find a common denominator between those things. Same exact skill, all right, different type of problem. All right, and in this case, a number that both 10 and 5 go into, I could say 50, right? 10 and 5 both go into 50. True, but that is not the smallest number that they both go into. What if I said 20? Do both go into 20? Yeah, but is that the smallest number they both go into? Now, what's the smallest? Well, 5 goes into 5, right? But 10 would, and then you corrected yourself before I even said anything. 10 is the number that both of those would go into, right? Now, I like to do the easiest work possible. So I'm not just going to assume that I want to get opposite x's. Let's also take a look at these y's. I think that would be a wise thing to do. So if I'm going for opposite coefficients for the y's, right now it's got a 3 and a 6. All right, we'll worry about signs in a moment. What's the smallest number that both 3 and 6 go into? 6 in this case, right? So when I do step 1, I analyze both of those pairs of variables. I figure out what would they have to be before me to get them to be opposites, and then I usually just pick the smaller of them, right? I like 6 is smaller than 10. And my only reason for doing that is because I live in a universe where doing math with smaller numbers closer to 0, is typically easier for us. That's the only reason. So, but you could choose 10. You could have gone for opposite x's. I would not mark you wrong in any way. You could get the right answer and you would have a great life. But let's try to get this 6. All right, so this equation already has a 6. All right, this one already has a 6. So I don't have to multiply this equation by anything. I like it. What would I have to multiply this equation by? Make this 3 a 6. 3 times what is 6? 2. And so what I'm going to do is multiply this entire equation by 2. This is technically a legal notation. Properly, what I should say is I'm multiplying this side by 2 and this side by 2. But tell you what, guys, we're doing our math on the street. We're on the black market of the internet over here doing our systems of equations elimination method. I'm just going to say I'm multiplying this whole equation by 2. All right, and that's going to give me opposite y's. Now, should I multiply by negative 2? No, because this one's positive and this one's negative. So I actually like the fact that those signs are already opposites. Okay, so we'll multiply this top equation by 2. So step 1, I'm multiplying this top equation by 2. 2 times negative 10x is negative 20x. 2 times 3y is 6y. Equal sign, lining them up. And 2 times 1 is 2. Don't forget to multiply the other side of your equation by 2. That's a super common place for mistakes. Mistake. Right? All right, so now step 1 is done. We did it. We did step 1. And let's follow through this whole problem because we can. The other ones I might just do setups for us. So, add them together. All right, negative 5x plus negative 20x is negative 25x. Negative 6y plus 6y. Those are conveniently opposite coefficients. I made that happen, right? We set ourselves up for success. Those guys just cancel each other out. There's 0 y's. I'm not even going to write it. Equal sign, and then 23 plus 2 is 25. All right? So it takes a little bit of work, a little bit of analysis, and that's the step we're going to work on today. But let's finish solving this problem so we at least get the reward of the answer. So I'll divide both sides by negative 25, and I get x equals negative 1 by the looks of it. Right? So if x equals negative 1, I can now solve for y, and I can plug this negative 1. I could plug it in here for x, I could plug it in here for x, or I could plug it in here for x. I think I'm going to actually choose this one. I think of these 3 equations, those are the friendlier. I just want to point out, even like this one that I modified, still is a legitimate equation that I could plug that into to solve for y. So let's see. So step 4, I'm going to plug this in for that x. So negative 10 times negative 1 plus 3y equals 1. Let's solve it. All right, there we go. So that's positive 10 plus 3y equals 1. If you guys are running out of space, you definitely can work on like another column. And labeling your steps, absolutely do that. It's a great idea for your own work, and then also if you're trying to pick up partial credit on a quiz or test sort of thing, then I can kind of follow your logic a little bit easier. So let's see, 3y equals, or 1 minus 10, what's that going to be? Negative 9, yeah, I subtract them and I took the sign of the more influential. Divide both sides by 3. And I get y equals negative 3. Negative times a negative became positive, so these two negatives combined. They became friends. They actually lived happily ever after. It's an amazing story. They're making it into a movie this coming summer. Great. Negative 10 and negative 1. Wow. The love story of our generation. Notice, right, we were able to solve using our other steps, using our normal means. But I'm interested now in, what about this setup? Let's do a bunch of step 1 problems together. Let's just master step 1. Okay, I want you guys to be like ninjas of step 1. I'll be your sensei, right? And this was the idea. I found out what number both of those would have gone into and multiplied one or both equations by what I needed to make opposite coefficients. So here, you guys, my students in real life, already have these problems written down. Let's take a look at this. First of all, are these lined up? X, Y equal constant. Yeah, I like that. All right. And do any of them have opposite coefficients right now? Well, the x and the 3x, I would need this to be like a negative 3, so that doesn't work out. And these have opposite signs, but their coefficients aren't. That's 3, and this is 1. I would need this to be a 3. So let's analyze this. For the x's, what does 1 and 3 both go into? What's a number that they both divide into? Like, so they both fit into 6, they both fit into 12, they both fit into 3. Man, why is my undo button lagging? All right, so those both fit into 3. And how about this? Between the -3 and the +1, what do these both fit into? Also 3. All right, so I don't know. It's a tie. Do you guys want to work for X's or Y's today? Doesn't matter to me. I could roll a dice. Let's see. I've got a 30-sided die here. If I get an even, I'll do X. If I get an odd, I'll do Y. I rolled a 6, so we'll solve for the X. Here we go. Let probability decide for us. So I'm going to multiply this equation by what to make this a 3? 1 times what would give me 3? 1 times what would give me 3? 1 times 1 would give me 1. So I need to multiply by 3. And if I multiply by 3, I'm going to get a 3x. And down here I have a 3x. But I want opposite coefficients. So let's multiply by -3, right? In order to get my opposite coefficient of -3x. Now careful with this, because I'm multiplying by a negative. And I'm essentially having to distribute this -3 times everybody, okay? So don't forget this minus sign. And one of you guys are going to forget. I know it. Don't worry, we'll work through it. Okay. -3 times 1x is -3x. Oh, look at those beautiful opposite coefficients. Guys, I just thought of something. Do you think, since we're mastering these problems today, that maybe it's our today selves, our future selves from yesterday's perspective, that maybe set up all of yesterday's problems for us in the past to be able to do? What if, like, we time traveled and published a math book in which step 1 was already done, and we're like, don't worry, past self, I'll help you out. I'll get you these opposite coefficients. That could be the case. We don't know. I don't know. I think so. I think that'll be the sci-fi story of this generation. They're making a summer blockbuster out of it. Let's see. -3 times -3y. Negative times negative is positive. 3 times 3 is 9. We still got the y hanging out. We got our equal sign, bringing it down, bringing it around town. -3 times 24. Don't forget it. Is going to be, well, 3 times 25 would have been 75. 3 less of those was 72, and it's going to be negative. All right, so notice I conveniently got opposite coefficients for my x's. All right, we'll go to step 2, because we want the joy of seeing those x's eliminated. All right, we'll go as far as step 2 for this problem. All right, add them up. 3x and -3x, eliminated, right? 0 x's. How awesome is that? 1y plus 9y is 10y. Equals, did I do this right? I don't know. 12 and -72. Oh, I did. Is -60. And I know you guys want to finish solving that, but I'm really want to make sure we're masters of step 1. So I'm going to move on to this next problem. I've got a bunch for us, so if you wanted to solve this later for practice, you could. You could. Actually, you could even solve it. Make your own YouTube video and make it a reply video to this one for those people in the comments that are going to be like, how do I do this? I really wanted to know the solution. All right, let's take a look at problem 3 here. This is from the monitoring progress section, question 3. To get opposite x's, right now I've got a 1 and a 4. What does both 1 and 4 divide into or go into? 4. All right, not bad. And how about for the y's, the 4 and the 1? What do both of those go into? 4. So it looks like a tie. I might go for the y equation, and my reason is this. Multiplying this equation by 4, I'd only have to multiply 13 by 4. But if I had to multiply like the top equation by 4, multiplying 22 by 4 sounds like that would be a big number. So I'm going to choose the y's in this case. All right. You could choose the other one. You'll still be perfectly accurate. So let's see. This equation already has a 4y. We're good. I like that. How do I get this to become a 4y? What would I have to multiply it by? 1 times what is going to be? 4. Yeah, multiply this equation by 4. But not only do I want it to be a 4, I want these to be opposites. So they're both positive now, so let's multiply by a negative 4, right? Right? Okay, here we go. Negative 4 times 4x is negative 16x. Negative 4 times 1y is negative 4y. And don't forget this other guy over here. Negative 4 times 13. Let's see. 4 times 12, 40, 52. 52, yeah, because there's 13 cards per suit, 4 suits per card, 4 times 13, 52 cards in a deck. That's why I know those numbers. It's 52. And don't forget this minus sign here, because a negative times a positive is negative. All right, so let's, if I was to do step 2, I would probably rewrite this first equation down here, just because it's weird to, like, add across 3 rows, right? And I don't want to make a mistake, so I'm just going to rewrite it. Right, we've got the space. The tree is already dead. Let's add them up. That's an ugly 2 right there. A little better. So negative 16x plus 1x will be negative 15x's. Oh, look at this. We set ourselves up for success. Negative 4y plus 4y is 0y, which is 0, and don't even write it. We eliminated it, guys. We did that. We did that. We coordinated its destruction. It was a conspiracy. And let's see, negative 52 and positive 22 looks like negative 30. And then you could solve from there if you really wanted to. But even though I want to, I want to make sure we get some extra practice. Okay, so we're just setting up this opposite coefficients. Here's some more problems for us. So if you guys, I don't know if these show up right away on your worksheet there, but here you go. Here you go. So these are technically from practice 5.3 part B. We've got 5.3a questions that you could practice as well for your class quest, so don't worry. I didn't steal the problems from your practice. I know you guys love practicing your math. Don't you fret. You got plenty of problems. Plenty of them. All right, so looking at these ones are getting a little trickier. All right, looking for opposite x's. What does 3 and 6 both go into? 6. It's got to be a number, right, bigger than or equal to both of them. So let's see, 3 goes into 6 twice, 6 goes into 6 once. But before I commit to this 6, because I don't know if I want to, how about these y's? What do both 9 and 4 go into? Oh my goodness. 4 times 8, 9 doesn't fit that. 4 times 3 is 12, 9 doesn't fit that. Let's see, that is one of the things you can do, by the way. Just write multiples of one of them. 4, 8, 12, 16, 9 doesn't fit. 20, no. 24, no. 28, no. 9 goes into 27. 32, no. 36, bingo! 9 fits into 36. All right, so like if you guys are like stumped, just start writing multiples of one of them and then find the least common multiple. Even if you wanted to start writing multiples of both of them, 9, 18, 27, 36, bingo! You could see, aha, those are the same, right? So so that's one of the things you could do. So 36 is the least common multiple between those guys. I definitely don't want to work with 36. I'm sorry. I'm going to work with 6, your square root. It's much smaller and younger than you. I'm sorry. Right? You're not going to be hired for this. Terrible, isn't it? That's a terrible world we live in. Let's see. So to get 6 here, this equation already has a 6x. And what would I have to multiply this by to get a 6? 3 times what is 6? Yeah, 2. And this is positive, this is positive. I need opposite. So I'm going to multiply by negative 2. All right, negative dose. You guys kind of see how I'm picking these numbers? All right, I know it's a little bit weird. That's why I want to just practice this skill quite a bit. And then we'll have you guys practice in a moment. Let's see, so negative 2 times 3x is negative 6x. Hey, look at those opposites. I love it. Negative 2 times negative 4y, positive 8y. Negative 2 times 19. Well, let's see, 2 times 20 would have been 40. and 2 less than that is 38. So 38, and this was positive, this was negative, so negative. And if I did step 2, we'll get the reward of the step 2 here. 6x and negative 6x is 0 x's. They were eliminated. I've got 17y and, oof. That 9 plus 8, 17 in the negative. Aha, wow, how convenient. It wasn't even going to have a fraction answer. So, all right, last question of this type, and then we might do one word problem real quick. All right, one word. Oh, actually, do I have to talk about this? Yeah, I might show you a chart, and then I'll do a word problem. There we go. All right. Yep. All right, between these x's, 3 and 4. What do both 3 and 4 go into? Well, let's see. 3, 6, 9, 12, 15, 18. Let's write down multiples of 4. 4, 8, 12. Bingo, got it. 12 is the least common multiple there. Find the LCM for these y's coefficients. So 5 and 2. Let's see. So 2, 4, 6, 8, 10. That's a multiple of 5 if I ever saw one. Yeah, 5, 10 right there. Bingo. All right, so if I have a choice between 12 and 10, which one do you guys want to work with? Yeah, we'll pick 10. And question 8, this one's interesting. This is actually the first problem where we have to, it says multiply if necessary, one or both. This is a problem where we'll have to multiply both equations by a constant. Okay, so I just want to point that out. It's the first time we've had that happen to us. So to make that 5 a 10, right? To make this 5 a 10, 5 times what is 10? 2. So I'm going to multiply this entire equation by 2. All right, but I've also got to make this 2 into a 10. Because, all right, so you're recognizing that both of these have the same signs. So I could either multiply this one by a negative or this one. Doesn't matter. We'll do this next one as a negative. And 2 times what is 10? 5. And yeah, so we'll make that 5 negative. Tricky, tricky, tricky. All right, so step 1. Let's deal with the top equation first. 2 times 4x is 8x. 2 times 5y is 10y. 2 times 3 is 7. No es más mal. All right, I'm worried about this multiplication right here, guys. Are you already getting like nervous? You're like reaching for your calculator. All right, let's see. Negative 5 times negative 3x is positive 15x. Those aren't opposites, but that wasn't the variable I was aiming for. Let's see if we get these opposite y's. Negative 5 times 2y is negative 10y. Oh, wow. Look at that setup. Man, it's like just like we're playing volleyball, and like step 1 is just kind of like lofting the ball in the air for us to do the spike on the second hit, right? It's going to be awesome. All right, and let's see. 5 times 38. Oh, my goodness, guys. All right, watch this. I'm going to do 5 times 38. I'll ignore the sign for now. It's going to be negative. Is the same as 5 times 40 minus 2. How about this math? All right, is 40 minus 2 the same as 38? Do you guys agree? Now, I'm picking that because I have an easier time multiplying by multiples of 10 than not. And let's distribute. 5 times 40, 5 times 4 is 20, plus a 0, so that's 200. Minus 5 times 2 is 10, so I get 190. That. So negative 190, what I get. Right, so I was actually able to use distributive property to help me figure out multiplication by a number that seemed scary to me. That's okay. Okay, and the negative times the positive became this negative here. All right, let's add them up because I know you guys, I got to give you the reward. Right, seeing those 10s eliminated, those jerks, right? That Y, I can't wait to take you out. Negative 184. Yeah, so 23x equals negative 184. Is this a problem that's nice enough to even have a, 23 might go into 184. It does, it fits in 8 times. So if you solve that as step 3, you would have gotten x equals negative 8. If you divide both sides by 23. All right, so that's step 1. Let me just do a quick summary know what? Actually, guys, I think for my real life friends, we actually have a half day tomorrow. I'm going to elect to do example 3 and maybe some of 5.4 tomorrow for the half day. I want to actually get my students some practice with elimination method. The next table that I was going to show you, tell you what, if you've watched this video and you were hoping for this table this whole time, it was, no, that's not the table. Undo. Here's the table. I'll show you the table, but I'm going to explain this in another video that'll come out tomorrow. All right, it's just kind of when to use which method. And so here it is. You could pause this and watch, check it out if you want. But I'll explain this more tomorrow. Thank you for watching, internet friends. We are going to practice some elimination. Bye-bye.